In this video, what I want to talk about is we're starting a new little bit here about quantitative analysis. And in quantitative analysis, what we're doing is we're determining the amount of something present in a sample. Okay. Um, so you have some sort of, I don't know, a solution of something, or you have a solid sample that has a mixture of things in it, or you have a compound you don't know what it is, um, that kind of thing. And we want to look at it and determine how much of something is there. Okay, it's kind of a broad general idea. Um, there are two kinds of this, and our first one of these, oops, is gravimetric analysis, and it's called gravimetric analysis. I'm guessing because we're talking about forming a precipitate, and that would involve gravity pulling the precipitate down, and so that should work that way. Well, I don't know what happened. Why can't I ever control the PowerPoint the way I'm supposed to? Okay, so in a gravimetric analysis, there are a couple of things that we're going to do. So in this example, what we're looking at here is silver nitrate reacting with sodium chloride. This is going to give us a silver chloride precipitate and leave behind a solution of sodium nitrate. And maybe you're doing this because you're going to add sodium chloride in there to figure out how much silver is in your sample, or you're adding silver nitrate to figure out how much chloride is in your sample. Um, Either way is okay. Uh, there's some steps we're going to follow when we do this. So you have some sort of sample. You don't know how much of a particular ion is in there. Um, and so what we're going to do is we're going to add an ionic compound that's in solution to precipitate the ion you want out of your original sample. Okay, so in this example, we're adding the silver nitrate to the unknown sample. And the goal here is, if we're adding the silver nitrate in there, is we want to know how much chloride is in the sample, and we're going to get silver chloride as the product to measure that out. Okay. Once we have the precipitate, we're going to isolate and dry it. We've seen this in lab already. Using a vacuum filtration setup, we can collect the precipitate up here. The liquid is going to flow through due to the vacuum pump. Um, yeah, and then we can let air go through this. You might even let it sit out over a few days or a week in a fume hood, or you might put it in the oven to dry it gently. Whatever. You're going to get all the water out of it to do that. Once you do that, you can measure how much of the precipitate you have. What is the mass of the precipitate? And the nice thing is, thanks to stoichiometry, the amount of precipitate relates to the amount of ion that's in your original sample. And so we can calculate how much chloride was in the sample, right? We can calculate this based off of how much precipitate was there. Okay, so let's take a stab working through an example, and I'm going to pause this while I find my calculator. Okay, I'm back. Hopefully you didn't miss me too terribly much. All right, here we go. So we've got a sample. This sample is 8.8633 grams, and it has an unknown solution, an unknown chloride concentration, and it has some cation with it. We don't care what the cation is for this example. We only care, well, we need the cation to be there so that the solution is totally electrically neutral. Okay, that's what we need that to be there for. Okay. Let's see. So what we're doing is we're going to add silver nitrate, just like we saw in the picture, and we're going to isolate silver chloride, and we've isolated 1.5615 grams of silver chloride. We're going to assume that's after the drying. Our question is, what is the mass of chloride in the original sample? Okay. All right. So we need to figure out how much um, how much chloride is in this sample. Okay. The moles of chloride between the original sample is equal to the moles of chloride in the silver chloride precipitate that we found. Okay, so That's our link between the original sample and the silver chloride. Okay, so our first part of our dimensional analysis is going to be to figure out how many moles of chloride, oops, six, uh, 5,615 grams of silver chloride. How much chloride is in this silver chloride? I've given us the molar mass of silver chloride so we can get there. 143.32 grams of silver chloride. Notice we're putting units and formulas on every step here. Okay, I've given us an anionic equation so we can see this, but 1 mole of silver chloride is going to give us 1 mole of chloride, right? Or contains 1 mole of chloride if we want to look at that. Okay, now that we have moles of chloride, we can figure out grams because ultimately we want grams because we have to figure out mass percent. So grams of chloride would be that 1 mole of chloride is 35.45 grams of chloride. And that's from the periodic table because we can assume the electron has no mass. So adding an extra one isn't going to make the mass noticeably different to 2 decimal places in terms of grams. All right, now let's math this out. 1.5615 divided by 143.32 times 1 divided by 1. I'm not doing that on my calculator. Times 35.45 gives us 0.386238482 grams of chloride. This should have 4 significant figures. 1, 2, 3. So there would be our significant figures if we stopped. Okay, we're not stopping, we're going on because we want mass percent. So let's get us some mass percent. Remember, mass percent is always grams of something in the total divided by total grams times 100. So here we're going to have grams of chloride, and we're going to be dividing this by the grams of silver chloride. Nope, 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 nope. Grams of sample. All right, this is going to give us the percent of chloride in our sample. Okay. Our chloride grams 0.386238482 grams of chloride. Whoops. Okay, chloride, there we go. And our total sample mass 0.8633 grams of chloride. Multiply that dude by 100. Calculator will take that number divided by our sample 8633, multiplied by 100, and get 44.7394% chloride. 4 significant figures is 44.74% chloride. Okay. Not too terrible. We could have asked for anything. I did a percent example because I wanted us to figure that out. But we could have been asking just simple moles of chloride, or we could have asked for grams of chloride, or percent of chloride, or maybe we know what the cation in the sample is. We wanted to know uh, how many, what the total grams of sample was, or I don't know. We could figure a lot of stuff out this way. So this is just one example. All right. Hope you're doing all right, and I'll catch you later.